Hey, what's up guys? It's Akshay from AS Learning, and today in this video we'll be discussing about the interview experience of a candidate. So he had 4 years of experience, and he was offered a package of 12 to 13, 14 on the basis of the bonuses and the variable pay. Okay, so let's go ahead with this experience. So the first thing which they asked was normal basic, just normal questions about what's his background and all those things. Later they shifted to basic ML questions and finally to the project based questions. Okay, so once after doing with the normal intro and all, we'll be shifting to the ML basic questions in which they tested his data science skill sets. Okay, so the first one is what is bias versus what is variance. So if you want to answer the question, it's simple. Bias is an erroneous term which gets introduced in your model when the model is in underfitting state, and variance is an erroneous term which gets introduced in your model when your model is in overfitting state. Okay. Generally, while training any ML model, this is how roughly we can see the model training graph appears. So the green curve which you can see is the curve of on the training data, and the red curve is the one on the test data. Okay, the black line which you can see is the bias versus variance trade-off point, and with the model complexity you have the prediction errors being plotted. So it starts with high bias and a low variance, and it goes towards low bias and high variance. So in the beginning the bias is high, the target is not met, and the training needs to be done to make the bias low, and at the end the variance becomes high when your model has overfitted. So whenever the training is done a lot on the training data and the model has not generalized properly, as you can see that after the bias versus variance trade-off point, the red curve is going up. So it means that the model has overfitted, and that typical point is the ultimate goal of building a model for a typical data set, and that point is called as bias versus variance trade-off point. We can understand the concept of bias versus variance into another graph. So here we can see that in high variance we have the data scattered and the data is spread out and the variance is quite high, while in case of high bias we can see that the targets are not being met and the predictions are way away from their actual targets. Okay, the next question was the difference between KNN and k-means clustering. So KNN is a supervised classification algorithm and k-means is an unsupervised algorithm. So KNN needs labeled data to train on, and once the training is done it would take an unlabeled data and tell whether in which class it falls. And in k-means it's an unsupervised algo. It will use for clustering, for creating different clusters and finding the insights in the data. So whichever, like how many clusters you want to find, you can decide on that, and on the basis of that what we can come up with is we'll be finding the distance of all these points with the centroid, and on the basis of that different clusters are being created, and to come up with the optimal number of clusters we can use the elbow method. Okay, so in graphical and in picture term we can see that in KNN we have two categories, A and B, and orange is a new data point, and the model is trained on category A and B, and then we have a question whether the orange data point would go into category A or category B. And in k-means, in the first image we can see we have random scattered data, and then after applying the algo we have 3 clusters being created. Okay, next question was how to handle missing data. So two major ways is deletion and imputation. In deletion you simply delete the data points. You can do deleting the entire row, pairwise deletion, or deleting the entire column. In imputation, if it's a general problem, and then you will have to impute categorical or continuous. So in categorical, we have some techniques like logistic regression. So by logistic regression, it means you can use an ML model to take its leverage while doing imputation. Then you have multiple imputations, and you have making NAS level. So by making NAS level, generally what people do is, if there are lots of NAs, so you can just simply add a 0 and make that typical column and its data point non-relevant. And multiple imputations means not just one imputation, but you can do lots of imputation on the basis of the different categories and some other properties which you can take into leverage. In continuous, people use median mode, and you have the multiple imputation and linear regression picture. In time series problem, how people approach is whether you have trend and seasonality, and on the basis of these three combinations, you have different ways like mean, median, mode, random sample imputation, linear interpolation, and seasonal adjustment. Okay. Then the next question was, what is topic modeling and what are the various techniques of it? So topic modeling is basically a statistical technique used in NLP for coming up with topics which would be a representation of the documents. So for example, if you have a corpus of news articles of India of past 3 years, and you have to come up with and your entire target is to come up with a goal that what happened in news in last 3 years in India. So in last 3 years in India, due to COVID, the stock market got crashed. That is a very important thing which should be detected, and such kind of things such kind of topics which you will be detecting out of these corpuses is called as topic modeling. So how it works is, you come up with, first of all, what happens is they randomly allocate the number of topics which you want to detect to all the words. I am talking about after the pre-processing step. In pre-processing pipeline, you have normal steps like stop word removal, stemming, and such kind of things. And after that, you have randomly topics being allocated to all the words in the corpus. Then what happens is they come up with an association of topic versus the document and words versus the document. And on the basis of that, what they come up with is they come up with a convergence point in which that word will make sense with the topic. And at the end, you will have probabilities and that topic which would be a representation of those documents. If you didn't understood it, it can be a case. So I have a detailed video of topic modeling using Jensen. I have given the link in the description. Do check it out. 15-20 minutes video in which I have explained step by step what topic modeling is and how you can implement it using Jensen. I highly recommend you. Okay. So, and the most popular algo which is used in topic modeling is latent Dirichlet allocations, and you also have other algos like LSA and RP. Okay. The other question which was asked was, what is confusion matrix? So let's discuss that. So this is how confusion matrix appears. You have actual value, predicted value, you have TP, TN, FP and FN. TP means true positive, TN means true negative. Then you have FP, which is also called as type 1 error, false positive. So what FP means is, FP means that it is predicted that it is positive, but actually it is not. So it's a false positive. And false negative, when it is predicted negative, but actually it is not negative, so it's false negative. Okay. Then from this TP, FP, FN and TN, you can derive lots of other formulas and combinations, like you have F1 score, precision, recall. For example, if you have TP is 200, TN is 50, FP is 10 and FN is 20, so you can calculate the accuracy as TN plus TP upon the total predictions. The accuracy will be 0.89. You have recall TP upon the actual S, precision is TP upon the predicted S, and then you have F1 score, which is an harmonic mean of precision and recall. So by recall, you get an idea out of the actual yes in the system, how many are really detected by model, and by precision you come to know how much जितने भी yes मॉडल ने प्रेडिक्ट किया उसमें से कितने एक्चुअल में yes है. Okay, so that's the difference between precision and recall. It's also another fundamental question asked: what is precision, what is recall? They discuss a lot on different metrics. These are the metrics used for classification problem, while in regression problem statements you have other metrics like mean absolute error, um, mean squared error, you have edges in R square and such kind of things. Okay, then the other question which was asked was multi-collinearity. So multi-collinearity occurs when two or more independent variables are highly correlated with each other in a regression model. In a regression model building, and VIF is one of the way of solving this. So the formula of VIF is 1 upon 1 minus R square, and VIF is called as variation inflation factor. And if the VIF is 1, it has no multi-collinearity. If the VIF is less than 5, multi-collinearity is less or it is moderate. If it's greater than 5, it's high and you might need to discard the variable. Okay. Then you have tolerance, which is the reciprocal of VIF. If VIF high, tolerance is low and it has high multi-collinearity. If VIF is low, tolerance is high and it has low multi-collinearity. Okay. What are the solutions for multi-collinearity? Dropping the variable, causing the problem. Standardizing the variables, you can standardize the variables, you can apply region lasso, and you can decode the form of independent variables. So you can split the variables, convert its form in this way. Okay, so by decode the form, you mean that if the temperature was in Celsius, you can convert it into Fahrenheit, so such kind of thing. And the other question which was asked was what is lemmatization stemming. Crude chopping of words is lemmatization. Bringing the words to root dictionary form is crude chopping of words is stemming. Bringing the words to root dictionary form is lemmatization. Faster, stemmers are faster. Lemmatization is slower. For example, carrying crude chopping, it will remove ing, car, stemmer. Carrying, K-A-R-E, lemmatizes, it will bring the root dictionary form. These are the different examples, the different famous stemmers: Snowball, Porter, Lancaster, Reid stemmer, and in lemmatizers we have worded lemmatizers. Okay. Then you have term frequency and inverse document frequency. So term frequency means the number of times a word occurred in a document upon the total number of words in document, that is TF. And then you have IDF, inverse document frequency, gives importance to rare words and cut out the weightage of common words like the etc. So the formula of IDF is log of total number of documents upon total number of documents with that word. So it is so basically what TF IDF is, it's a numerical representation of the words. Okay, and it works in the concept of frequencies and occurrences of words. So let's try to understand it in much detail. Now this is how you can implement TF IDF. And for example, if you have in a document you have 500 words, okay, and Virat Kohli occurs 5 times, so TF is nothing but 500 upon 5 upon 500. Okay, now for example you have 10,000 documents, okay, and documents with the word Virat Kohli is 300. Okay, then IDF will be log of 10,000 upon 300, and the multiplication of these two things will be your TF IDF of the word Virat Kohli. And last but not least, they discussed about the project related questions. Okay, there's one more interview question series which we made, I think, of Mindtree. So the link is there in the description. Do check that also. And yeah, if you like this video, give it a thumbs up. Share it with all your friends. all your friends. Do check the AI playlist and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.